Summary table of trigonometric ratios. Welcome, everyone. Before we dive into our main topic today, let's take a moment to reflect on what we have already covered. In our previous lessons, we didn't just memorize numbers. We actually used geometric methods to derive the trigonometric ratios for specific, important angles, specifically 30 degrees, 45 degrees, and 60 degrees. We also looked at what happens at the extreme ends, exploring the limiting cases for 0 degrees and 90 degrees. Now, while deriving these from scratch is great for understanding the why, it can be quite time-consuming during an exam or a complex problem. So, to make these values much more accessible and efficient for your problem-solving, we are going to consolidate all of that information into a single, handy reference table. This table is going to serve as a fundamental tool in your trigonometry toolkit. Once you become familiar with it, it will allow you to quickly identify the ratio of sides for any of these standard angles without having to redraw a triangle every single time. Let's take a look at that table now. Table 8.1, Trigonometric ratios of some specific angles. Now that we've discussed why we need a consolidated reference, let's take a close look at the actual data in Table 8.1. This table provides the exact values for the 6 trigonometric ratios: sine, cosine, tangent, cosecant, secant, and cotangent, for the most commonly used angles in mathematics and physics: 0, 30, 45, 60, and 90 degrees. If you look at the first row for sine A, you'll see the values start at 0 for 0 degrees and gradually increase to 1 at 90 degrees. Notice the pattern of the square roots in the middle, like 1 over the square root of 2 for 45 degrees. As we move to the cosine A row, you'll notice something interesting. The values are actually the reverse of the sine values. It starts at 1 for 0 degrees and decreases down to 0 at 90 degrees. This symmetry is a key feature to keep in mind. For tangent A, the values start at 0, move through 1 over the square root of 3 and 1, up to the square root of 3, and then we hit a point where the value is not defined at 90 degrees. This happens because, as we will learn in our common mistakes slide later, we cannot divide by 0. The next 3 rows, cosecant A, secant A, and cotangent A, are the reciprocal ratios. If you look closely, you can see they are simply the flipped versions of our sine, cosine, and tangent values. For example, since sine of 30 degrees is 1/2, cosecant of 30 degrees becomes 2. I recommend you don't try to memorize every single number right away, but rather focus on how these values relate to one another. In the next slide, I will show you a very efficient way to navigate this table to find any value you need during an exam. How to use the summary table. Now that we have seen the complete table of values on the previous slide, you might be wondering how to use it efficiently during an exam. Don't worry, it is actually quite straightforward. To find the value of any trigonometric ratio for a specific angle, you just need to follow these 3 simple steps. First, identify your angle. Look at the very top row of the table, which contains our standard angles, and find the specific angle mentioned in your problem, for example, 60 degrees. Second, identify the ratio. Now, look at the leftmost column to find the specific trigonometric ratio you are looking for, such as cosine A. Third, find the intersection. Simply move your finger across the row for your chosen ratio and down the column for your chosen angle until they meet. The value written in that specific cell is your answer. Let's walk through a quick example together to make sure this is clear. Suppose you are asked to find the value of tangent 30 degrees. Step 1, locate the column for 30 degrees at the top of the table. Step 2, locate the row for tangent A on the left. Step 3, follow them to where they intersect, and you will see the value is 1 over the square root of 3. Once you master this technique, you'll be able to use this table as a powerful tool for the real-world applications we are about to discuss in the next slide. Real-world application, engineering and architecture. Now that we have mastered how to read the summary table, let's step away from the textbook and see how this actually works in the real world. You see, these trigonometric ratios aren't just abstract numbers on a page. They are incredibly powerful tools used every single day by professionals like civil engineers and architects. They allow these experts to calculate precise heights and distances that would be nearly impossible or even dangerous to measure physically with a tape measure. Let's look at a practical scenario. Imagine an architect is designing a ramp for wheelchair access. To ensure the ramp is safe and easy to use, it must be inclined at an angle of 30 degrees to the ground. Now, let's say the total length of the ramp, which, as we know from our study of right-angled triangles, represents the hypotenuse, is 4 meters. The architect's goal here is to determine exactly what the vertical height of the ramp will be once it's built. To solve this, we can follow a simple step-by-step calculation, just like we practiced. First, we identify our known values. We have our angle, A, which is 30 degrees, and our hypotenuse, H, which is 4 meters. Second, we need to choose the correct ratio from our table. Since we are looking for the vertical height, which is the side opposite to our angle, and we already know the hypotenuse, the sine ratio is our best choice. We can express this as sine of A equals the opposite side divided by the hypotenuse. Third, we refer back to the summary table we just reviewed. If we look at the column for 30 degrees and the row for sine A, we find that sine of 30 degrees is equal to 1/2. Finally, we substitute that value into our equation and solve. We set 1/2 equal to the height divided by 4. To isolate the height, we simply multiply 4 by 1/2, which gives us a result of 2 meters. So, through the use of trigonometry, we have determined that the vertical height of the ramp is exactly 2 meters. As we move to the next slide, I want you to keep this logic in mind, because I'll be highlighting some common pitfalls where students often trip up when performing these exact types of calculations. Common mistakes to avoid. Now, before we wrap up our session, I want to pause and discuss some common pitfalls. Even if you have memorized the table we looked at in slide 2, it is very easy to make small errors during an exam. Let's look at 3 specific mistakes to avoid. First, watch out for confusing your sine and cosine values. I see students swap the values for 30 degrees and 60 degrees all the time. To keep them straight, remember that sine of 30 degrees equals 1/2, while cosine of 30 degrees equals the square root of 3/2. A great mental trick is to look at the trend. As the angle increases from 0 to 90 degrees, the sine values steadily increase from 0 to 1, whereas the cosine values do the exact opposite, decreasing from 1 down to 0. Second, don't be confused by the term not defined in the table. When you see this, for instance, with tangent of 90 degrees, it isn't just a random label. It actually means the ratio involves division by 0. If you think back to our identities, tangent of 90 degrees is equal to sine of 90 degrees divided by cosine of 90 degrees, which simplifies to 1 divided by 0. Since we cannot divide by 0 in mathematics, we call it undefined. Finally, be very careful with reciprocal errors when working with cosecant, secant, or cotangent. It is easy to grab the wrong primary ratio. Always double-check that you are taking the reciprocal of the correct partner. For example, if you are looking for secant of 60 degrees, remember that it is the reciprocal of cosine of 60 degrees. Since we know from our table that cosine of 60 degrees equals 1/2, then secant of 60 degrees must be 2. Keep these tips in mind, and you'll find much more success when applying this table to complex problems. Key takeaways. First, regarding consolidation. Remember that Table 8.1, which we looked at earlier, is your ultimate cheat sheet. It summarizes all the essential trigonometric ratios for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Having these memorized or easily accessible will save you a lot of time during exams. Next, I want you to notice the beautiful symmetry present in these values. If you look closely at the table, you'll see that sine of 30 degrees is exactly equal to cosine of 60 degrees, and similarly, sine of 60 degrees equals cosine of 30 degrees. This leads us directly to the concept of the complementary relationship. In trigonometry, the sine of an angle is always equal to the cosine of its complement. A perfect example of this is 45 degrees, where sine of 45 degrees equals cosine of 45 degrees, which is 1 over the square root of 2. Finally, let's remember the practical utility of this entire lesson. This table isn't just a collection of numbers. It is an essential tool for solving real-world problems, much like the architect's ramp example we discussed. Whenever you are faced with a right-angled triangle problem where you know at least one angle and one side, this table will be your best friend. All right, we have reached the end of our lesson. Let's wrap everything up by looking at our key takeaways to ensure you have a solid grasp of what we've covered today. Great job today. Keep practicing these values, and I will see you in the next session.